Today we are going to conduct an experiment to determine the concentration of colored solutions using a colorimeter. Photocolorimetry is a method for determining the concentration of colored solutions. And the main device which is used for this is called a photocolorimeter. Photo is from the word photon, which means that this device works on the phenomenon of light absorption. Let us take a look at the structure of this device. This is where the light source is an ordinary incandescent lamp. There is a filter or monochromator after it, and now it is set at a wavelength of 670 nanometers, which means that after passing through the filter, red light passes through. In this part, there are two windows for the passage of the light and a moving table for placing cuvettes on it. The light passes through the window, enters the cuvette with the test liquid, passes through the cuvette, and through the second window enters the photocell. A photocell is a device which operates on the phenomenon of an external photoelectric effect. The function of a photocell is that this device converts the energy of light that falls on its surface into electrical energy. Here we have got a scale. On the lower scale we can determine the optical density of liquids, and on the upper scale we can determine the transmittance. In today's work, we must determine the dependence of the transmittance first, on the length of the cuvettes, which is the length of the optical path. Second, on the concentration of colored solutions. The vessels into which the test liquids are poured are called cuvettes. We have cuvettes of different lengths. These are 50, 30, 20, 10.5 millimeters. And today we will work with a blue stain solution of 10, 20, 30, 50, and 80% with an unknown concentration. As a result of our experiment, we will determine the unknown concentration. We will carry out the experiment by the comparison method, which is using two liquids. This is a colored solution, and we will take pure water as a reference liquid. Let us start our work. For this, we take cuvettes of the same length. We will pour clean water into one and install the first cuvette on one side of the table. Into the second cuvette, we will pour a colored solution with 30% blue content. In this part, we will be working with constant concentration. First, we will set up the table so that the beam of light passes through clean water. The light passing through the filter passes through the water and falls on the photocell. The photocell converts the intensity of light falling on its surface into electrical energy, which in turn deflects an arrow on the scale. Since we are using the comparison method, assuming that when there is no light absorption through clear water, we set the arrow to 100 with the screw. After that, we change the position of the table so that the light passes through the colored solution. By reading the scale, we can determine the transmittance. For instance, with a 50 mm long cuvette, the transmittance is 50%. This means that 50% of the light is absorbed to the colored solution. Let's change the cuvettes. Let's take a 30 mm long cuvette. It is necessary to shake the bottle with the colored solution because after a while of being at rest, the paint particles settle on the bottom of the vessel and the concentration of the solution changes. Now, let us pass the light through clean water, set it to 100 and change the position of the cuvettes. In this case, the light passes through the colored solution and on the scale the transmittance is 80%. Some part of the light is absorbed. In this way, by changing the length of the cuvettes by 20.10 and 5 mm, we must determine the transmittance and the addiction. We denote the length of the cuvettes by the letter L, and it can be called the length of the optical path of the light. As a result of this part of the experiment, you need to fill in the table, plot the dependence graph. On the horizontal axis, we mark the length, and on the vertical axis, the transmittance values. In the second part of the experiment, we will determine the dependence of the transmittance on the concentration. In this case, the length of the cuvettes will be constant. We will change the concentration. We are going to pour clean water into one cuvette and set it on the inside of the table. Let's start with a 10% solution. We pass the light through a cuvette with clean water and set it to 100%. To determine the transmittance of a 10% liquid, we change the position of the stage and pass light through the colored solution. On the scale, we define 79%. This means that light passing through the colored solution is absorbed, and only 79% of the light intensity passes through. Change the solution in the cuvette to a different concentration. Let's take a 30% liquid. With the 30% solution, the transmittance is 48%. Let's take a 50% solution. At this concentration, the transmittance is 28%. The transmittance of an 80% solution is 15%. And at the end, we will determine the transmittance of an unknown concentration. And it is equal to 52%. With the help of a photocolorimeter, today we carried out work to determine the concentration of colored solutions. In order to determine the unknown concentration, first we need to build a graph of dependence using the obtained data, and from this determine the unknown concentration.